record. Okay, these are the instructions for an opportunity. Again, it is optional. You do not have to do this. But my thought is that there is no reason to not do this because this should be super helpful. Okay. The only thing I would say is if you're completely swamped this week and that your average is sitting pretty, then maybe don't worry about it. But if you know you need the help, and the idea behind this is that if I was struggling in a specific area, I would pick that one because it will make you review it. So you are doing a rapid review. This is not like a 20-minute review. This is like, I would say, under a couple of minutes of one of these topics. If you pick, let's say I pick rational functions, and then underneath it, that video has to cover everything that's underneath it. Not one thing from underneath it, but everything from underneath it, okay? I tried to go in order. There are some that blend together, but your goal is a simple, rapid review. You don't need to go through like a big, long explanation or a big, long example. Simply how do you find those things? So for rational functions, you'd be looking at horizontal asymptotes, vertical. How do you find these things? Horizontal asymptotes, vertical asymptote, slant asymptote, zero, a whole, including the limit notation. Like how do you represent the whole using limit notation? And then end behavior again in limit notation, okay? If you're doing graphs of polynomials, this is how to find your zeros and your multiplicity. How do you find end behavior? How do you find the interval of a graph that is above or below the x-axis or above or below 0? How to find the zeros and your max and min from a graph and calculator. How to find increasing and decreasing behavior, concavity, and points of inflection. If you're doing exponential functions, identify the difference between growth and decay, find your end behavior, find your horizontal asymptotes, and then given 2 points, how do you find the equation of the exponential function? Then came inverses, finding inverses from points, finding an inverse from an equation, determining if a function is invertible, and then finding the inverse from a table. Log functions, evaluating logs, like your simple straight up mental math. Graphs of logs, indicating zeros, transformations, and vertical asymptotes, and then expanding and condensing log expressions. Then classifying types of functions, linear, quadratic, cubic, quartic, exponential, log. From a chart, finding the regression using a graphing utility, finding the residual value, and then determining if it's an overestimate or an underestimate. Then sinusoidal functions, the shape of the parent functions of sine and cosine, how do transformations work on the equations, how to find A, B, C, and D, given max, min, period, that kind of thing, how to find the coordinates given your max, min, and your period. Remember, that is one of your FRQs. Tan, cotangent, cosecant, and secant graphs, the shape of the parent function, how to find the asymptotes, and how to find the period. Trig, inverse trig functions, trig equations and inverse trig functions. What is the difference between solving sine of x equals 1/2 or sine -1 of 1/2? Like, what's the difference there? With and without an interval. So am I adding 2 n pi? Am I adding n pi? How to solve a multiple angle equation where it would say like sine of 3x equals something like that. How to find the inverse trig function, sine -1, tan -1, cosine, and cosine -1 with their restrictions, and then include the identities in the double angle formula. So you simply have to include what they are. Sine squared plus cosine squared equals 1. Tan squared plus 1 equals secant squared. And your double angle formulas. You literally just have to review them. And then the last one is your polar coordinate and functions. Plotting polar coordinates, finding the parent shape of a rose, a limicon within the limits on all 4 types, and what to find with each one. If it's a rose, you need to know the number of petals, the length of the petal, that kind of thing. If it's a limicon, you need to know your max and your min and your symmetry. And then symmetry for all of them. How to find the rate of change and how to find the increasing and decreasing behavior of the distance from the pole. That's like if the R is positive and increasing, then the distance is increasing. If the R is negative and increasing, then the distance is decreasing. Like that little rule, okay, that we did at the very end of Unit 3. Questions on this opportunity? Yep.
How many points are you going to get?
I would say probably 5. It will also kind of depend on what the average is on this test. Like if I need to give more, I could give more, but probably I would say 5. And again, instead of going with your gut and saying, ooh, that one's easy, let me do that one, don't. Go with which of these did you just recognize the least? and make yourself learn it so that you can do that video. That would be the best way to take advantage of something like this. Do you have a question?
If you pick like one of them, can you do like one problem?
Like encompassing all of it?
Yeah.
Sure. Like, so if I, like, for example, let's say you pick a rational function. The only thing I would say with that is if it has a horizontal asymptote, it doesn't have a slant asymptote. So you might have to do two different parts.
Okay.
But you can review, if this was, like, you don't have to go all, let's say you're going to slant asymptote and you've done all the other things with a horizontal asymptote. You can say slant asymptote is found by doing this. And you could say, for example, if the top had this power and the bottom had this power, I would divide it and get that. Like, you don't have to go all the way through the zeros and all the stuff.
Yeah.
Yeah.
Okay. Thank you.
You have a question? Yep.
Yeah. Just choose one of them, right?
Just choose one.
Okay.
Yep. One bolded thing with all the points underneath. Yes. Yeah. Yeah, like, so this should be an explanation. If you had watched the AP classroom videos that I shared with you, you would see within those videos, they do these little rapid reviews. So if you haven't seen one of those videos yet, I would strongly recommend, like I said, you can even put it on double speed and it takes 9 minutes of your life, okay? But it is a review. So like if you go to Unit 1, in Unit 1, they review rational functions. And then you'll understand what they review and behavior. And then you'll understand what I'm talking about for if you want an example. It doesn't have to be a beautifully typed chart. Like, I don't care. It could be your handwriting as long as it's legible and as long as I can understand it.
And how many points?
I said probably 5, but it will really depend on what this average is like on Wednesday. Yeah. All right, I will say this about this 5 steps. I think the first one was a better review. Like, I think there's some weird questions in here. But so if you're prepared, if you want to review for Wednesday, then obviously this was a good way to start. But I would also go back to your first 5 steps, the one that hopefully you did like back over your spring break or the last week or so. And I would also make sure that if you needed, like, hopefully you wrote down stuff on your answer sheet to review from the ones that we did last week, okay? Because those are the best reviews, but those can't go home with you. Dane. 7. All right, number 1, let f be defined as x squared plus 3x plus 2 over x squared minus 1. Which of the following best describes the graph of f? So if you look at your answers, this is your whole. This is what we just went over. If you look at your answers, like I would look first because there might be ones in here that have infinity and negative infinity in there, and now you're talking end behavior. But these are all values, and they are all specifically to one value, which is x. If you took your function at the beginning and you factored it, x plus 1, x plus 2, over x plus 1, x minus 1, then you eliminate x plus 1, and all the x plus 1s are gone, which means there's a hole at negative 1, which now, if you look at your answers, that makes sense. And this is all asking what happens to negative 1 as it comes from the left. But it would be the same answer if it was coming from the right, too, because that's how a hole works. So now I have to take that negative 1 and plug it back into my updated function. So negative 1 plus 2 over negative 1 minus 1 is 1 over negative 2. So from both directions, it would be approaching negative 1/2. These would be if there was a vertical asymptote at negative 1. If there's a vertical asymptote at negative 1, you're either going positive infinity or negative infinity. But there was a hole there. The table gives the selected value. What's the average rate of change over the interval of negative 1 to 2? So I'm going to do f of 2 minus f of negative 1 all over 2 minus 1. F of 2 was 8. F of negative 1 is 2 over 1, and it's 6 over 1.
Your y's are on the top, right?
Yeah. What did I just do? This is plus. Thank you. Plus, that's 3. That's 3. So that's 2. Okay, 7 said if f of x equals 4 times 2 to the x minus 1 plus 3, then which of the following is f negative 1 of x? So you're finding the inverse of your equation, right? So
I got none of these, and then I tried being like, okay, well, I got none of these, so why don't I plug it back in to see which one gives me just x, and none of them.
did you get here? The 1/4 was on the front. Is that where you're at? Here, let's work it out. We'll talk about it. All right, so from here, like first thing we do is switch the x and y. Then we want to solve for the new y. So I would subtract the 3 x minus 3 equals 4 times 2 to the y minus 1. In order to get to the exponent, I got to get rid of the 4. So dividing by 4 or multiplying by a fourth gets rid of that. 2y minus 1 is here. 1/4 x minus 3. And then if I want to get to the exponent, I log base the same thing on both sides, but it's got to be the base of this guy. So it'd be log base 2 of 1/4 x minus 3 equals log base 2 of 2 to the y minus 1. Log base 2 of 2 cancels.
You have to I thought you had to expand, but.
But wait, hang on. Let me add the 1, Okay, so now you're here, right? So this, if you looked for it, was not there. So f negative 1 of x. Log of 2, 1/4 x minus 3 plus 1.
I'm thinking maybe they did, since it's x minus 3 divided by 4, maybe they did log base 2 of x minus 3 minus log base 2 of 4.
Oh, you made it a minus. So I separated it, expanding it. Log base 2 of 1/4 plus log base 2 of x minus 3. This would still be plus 1. And then this is, in order for 2 to go to the bottom, it has to be a negative exponent. And for 2 to go to 4, it would have to be negative 2.
We have to expand it first.
I mean, if your answer was there, of course not. But if you look, this answer is not here. Like, this answer is not in there. So I knew how to keep going.
Wait,
So then from here, it was expanded. It was multiplication. So when you expand it, it becomes addition. Log base 2 of 1/4 is negative 2. And then you're combining negative 2 and positive 1. So log base 2 of x minus 4 minus 1. And that was the first choice.
I got that, but I wanted to ask if, in terms of that actual question, when you're plugging back in, isn't it supposed to give just x? I don't think
If you do f negative 1 of f of x. So you have to put f of f negative 1 of x.
Yeah.
Or f negative 1 of f of x. That should give you x.
Because when you put that into there.
As your x?
Yeah.
You put that in your exponent? Or you did the other way around?
Put in the exponent. And then you would get minus 2.
I mean, I wouldn't even try to simplify that all the way out, but you should get x.
Okay.
Yeah, I mean, later with time we can look at it, but I feel like it says, sorry, I did this so long ago, I don't even remember. The table gives selected values of the polynomial. Which of the following must be true about it? Because, so I mapped it over here, right? You have a 0 at 0, 0, negative 318, negative 220. You don't know if it goes higher between here, is the problem.
It says global, right, which means absolute.
Yep. So you don't know. It is the maximum value there, but there could be a value in which it brings it up higher than that and comes back down.
Or it could go higher.
What about local? Does it go from 0?
Local is because that within that range between 0 and 3, there is a local min. You don't know what it is, right? But you know it's a local min because it's at 0 and 0. So if I have consecutive zeros,
Oh, so it's saying there's one in between.
correct. Yep. Yeah.
When you got the original answer, if you just
Okay, 5 says the graph of the rational function has a hole at 2, negative 1. Okay, then it says if f is 2 of x. So if, this is talking about transformations, right? If they're multiplying something inside the parentheses, what kind of transformation is that? It's a dilation, a horizontal dilation, right? Dilation by a half. And horizontal is x or y? X. So you take your x value, this was your coordinate point. You take your x value, multiply by a half. And that's where you get your updated coordinate. So I think that's a fair question. Like I said, some of them were weird. 7 was a little weird, but for the most part, All right. Oh, it's also an inverse question. All right. F of x is x plus 1 over x minus 2. Which of the following represents f negative 1 is the inverse function? So same process. You're changing your y, which is your f of x, to x, and your x's to y's. And then we got to solve for the new y. So I got to multiply x, y minus 2x equals y plus 1. And then as soon as you see there's two of the same variable, and that's what you're trying to solve for, you got to get those terms to the same side and the other two to the other side. So I'm moving this y over here, x, y, minus y, and I'm moving the 2x to the other side. 1 plus 2x or 2x plus 1, that order doesn't matter. Then I want to factor out the y, x minus 1 equals 1 plus 2x, and then I want to divide by it. So y equals 1 plus 2x over x minus 1, and this becomes f negative 1. And then if you look at your answer choices, I don't know if that was in that order, it was flipped. It was flipped here. 2x plus 1 over x minus 1.
So when you do like when you switch the variables, which one are you solving?
The new y. Yeah. It doesn't mean that they're bad questions. Okay, 8 says, which of the following is true about the graph of cosine of theta? So I know cosine of theta. If you need to visualize it, looks like this, right? This is your pi over 2. This is pi. This is 3 pi over 2. And then it says, like if you go through your answer choices, it says it's identical to the graph of sine theta plus pi over 2. Well, sine theta plus pi over 2 would be your sine curve shifted to the left, pi over 2. And that's exactly what matches it. The input values increase without bound. The graph increases without bound is false. It stops at 1 every time. The graph has rotational symmetry and is therefore odd. This actually has even, it would be even, it's symmetric to the pi over 2, which means it's an even symmetry. And the frequency of the graph is 2 pi. The period is 2 pi. The frequency is 1 over 2 pi. So A was the only one that was true. All right, 13 says, which of the following is true about the graph of negative 2e to the negative x? So e base is still just exponential. So that could be any exponential, okay? But e is about a 3. So let's say this is like 3 to the negative x. Let's approximate it because you won't have a calculator if it was something like that, right? So the multiple parts on your exponential, if it's a parent function with a base that is a whole number, it would normally rise as you go to the right. But because of the negative x, it puts it in the bottom. So this is like negative 2 to the 1/3 raised to the x. Now it's decreasing as you continue. So it would be like that if it was just the 1/3. And then because it's a negative 2, it flips it upside down. So now it's this guy. So as it approaches infinity, it's approaching your horizontal asymptote from the underside, but still the horizontal asymptote, which is at 0. The horizontal asymptote gets shifted if you add or subtract a number after it. So if it said negative 2e minus x minus 1, now a horizontal asymptote's at negative 1. If it said plus 1, now a horizontal asymptote, so it's positive 1. So with your vertical shift comes the change in your horizontal asymptote for exponential. 12, yeah. All right, it says consider the equation log base b of c equals a. Which of the following statements is true? So b can't be negative. Like your base on a log can never be negative, so I ruled that one out. C can't be negative because there can be no log that results in a negative. Like, so if it starts as a positive base, I can never get a negative answer, right? If your base is positive, no matter what I raise it to, it will never be negative. It will never be 0 and it will never be negative. The where the C is, yep. So this has to be greater than 0 by rules of logs. So that rules out C. And then it says the values of A, B, and C must be positive. Well, A doesn't have to be positive because we can raise something to a negative exponent. So that's why it's A. Something to a negative exponent just makes it a fraction. It can be done. Yeah.
Isn't it like if you have like a negative initial value and you raise like an odd exponent, it can like still be negative?
That you're talking about a coefficient, not a base. So like if it's negative 2 raised to the 3rd power, that could be negative 8. But you're taking a value here. That number on a log can never be negative. Yeah. Yep. 27. Okay, 15 says, which of the following equations is true? So this is your inverse stuff, remember? It says sine, cosine, tan. So think sine is the right side. Sine and tan are on the right. Upside down is awful. And cosine is at the top. So sine of 3 pi over 2, that's positive 3 pi over 2. That's actually pi over 3, so that one's wrong. Tan -1 of -1. The negative happens in the second quadrant and the fourth quadrant, but we don't use the second quadrant, which means 3 pi over 4 is wrong. Cosine -3 pi over 2 is in the second quadrant, which would be 5 pi over 6. That's the one that's right. And then tan √3 over 3, tangent you only pull from the first quadrant, which would have just been pi over 6. So that's the only one that's in the right restricted area. Yep.
So, for restrictions, if we have an equation that we're trying to like,
If you bring in the -1, you don't worry about a restriction. It's when it's printed for you. That's when you restrict it. So if it had said tan of x equals -√3 over 3, so we inverse tan it to solve it, then we don't restrict it. That would be negative. It's going to have two answers, right? It would be it would be 5 pi over 6 plus n pi. And it would be, oh wait, that one repeats. It'd be 7 pi over 6 plus n pi, but you don't need the n pi. This is what your answer would be. Because tangent you only need the top, and then you add the n pi.
so when it's there printed, you need to use your
Correct.
restriction, but if you bring
When you bring it in, you're not really inversing it. Yeah,
Tangent and sine for you, from what you're looking at, is like this.
the right.
Cosine's like that.
Correct. Yeah. Oh, hang on 2 seconds. All right, so 12 says log base b equals a. So properties of, wait, there's a variable here. C, thank you. Properties of logs basically answer these questions. The base on the log is never negative, which means we rule out D. The answer for a log, or what you're trying to find a log of, can never be negative or 0. It has to be greater than 0, which rules out C. And then it says that the value of A can be negative, or they all have to be positive. Well, B and C have to be positive, but A can be negative, because I could say, like, B to the negative exponent. I can do that. So A does not have to be positive, which means A was the only answer.
Why can't be negative?
Your base on your log can never be negative. It's like a rule of logs. That this can never be negative. Neither of them can be negative. But this also, C can't be 0. So this has to be, whatever's down here has to be bigger than 0. And whatever's here has to be, well, this, yeah, bigger than 0.
Okay. Thank you.
Yeah. No.
But can C equal 0?
C, no. No, because there's no answer that turns something to 0. If you never start with 0, you can never get 0. Does that make sense? Okay. Yeah. She's going. And if you can never start negative, you can never get negative.
But if your B was negative, wouldn't that put it like incorrect?
So your B can't be negative. Your in parentheses would be, you mean like, are you talking about transformations? Like this?
I mean, like, you can do -3 squared and get to...
Right, but not on a log. No, not on a log. Yeah. Yeah. 13. What's true about the graph of, I wrote all over this sucker, -2 e to the negative x. All right, guys, shh. This is an exponential function. So if the e throws you, remember e is like 2.7. You could literally change it to the number 3 and go from there. That will give you its shape. So if the e itself is what messes with you, change it, because it's 2.7, same, very similar. So the negative on the front, well, first of all, start with your base function. This is raised to a negative exponent. What does a negative exponent do? Makes it, you can either flip your graph over, or it makes your base a fraction. Either way you do it, right? So either I look at 3 to the x like this, and then if there's a negative here, it's a horizontal flip. So it flips it this way. That's one way to look at it. Or the negative makes this 1 over 3 to the x. And that is also this shape, because it is decreasing as you move to the right. So a fractional base means, or decimal less than 1 base would mean it was falling as I move to the right. Now the negative on the front flips it over the y-axis. So now it's like this. So as the end approaches positive infinity, my values are approaching my horizontal asymptote. The horizontal asymptote is at 0. There's no vertical shift, because that's what changes a horizontal asymptote.
I know it's at 0.
The parent function is at 0, and it shifts with a vertical shift. So if it said negative 2e to the negative x plus 1, my horizontal asymptote just went up to 1, which is what would affect the end behavior. Yeah.
So, because it's an E, like.
It's just exponential.
It's log.
No, if it says ln, it's log. ln is log base e. E by itself is 2.7. Yeah. All right, 17 says, let f be a rational function. When f is graphed in the xy plane, which of the following statements is true? So if I look at my answer, they're all about the roots, which is like your zeros. This one had an x minus 2 squared in the top times x plus 3, and then an x and an x minus 2 and an x minus 1. If there are 2 x minus 1s in the top and 1 in the bottom, I eliminate one of them. But this would still be x minus 2 and x plus 3 over x times x minus 1. When you cancel this, there's a hole there, which means it's not a 0. There's a point, but it's an open dot, so it doesn't count as a 0. It does, but because we eliminated it at that coordinate point, which if it was a 0 at 2, how would you find your how would you find your y coordinate? Plug it back into the new one, right? So I'd get 2 minus 2 times 2 plus 3 over 2 times 2 minus 1. 0. This is not a 0, though. At 2, 0 on your graph, it's an open dot.
You don't even need to do it because it's a function, you know it carries.
Huh?
I said you don't even have to do the math because it's a function, it can't have multiple lines or anything like that.
No, a function can. You're thinking invertible. No. Multiple zeros. So you can have a 0 repeat twice. Remember, that's where it would bounce at that point. Yeah. Yeah, but you wouldn't get that from your zeros. So this should have been B. You wouldn't get, zeros are not the multiple y's, zeros would be the multiple x's. Yeah.
You don't have to plug it back in.
Oh, no, I said if it asked you how to find a hole, right? So, and if I was how would you do a limit notation of a hole? Like if there's a hole at 2, 0, what does your limit to notation look like? So I'd go 2 from the left, and then I'd go 2 from the right, and the y would be 0 for both. All right, other questions? Yeah. Okay, 17. Oh, and this was, yeah, well, roots are the same thing as zeros. X minus 2 squared. A root is a 0 or a solution. All right, first of all, what's happening in this rational function?
There's a hole.
You're crossing out an x minus 2 in the bottom, and that whole thing is gone. If that was reversed, if it had said x minus 2 in the top and x minus 2 squared in the bottom, how does it change it?
There's not a hole.
It's not a hole. You eliminated a 0, but not a hole. Does that make sense?
Wait, what'd you say?
If I had said this said x minus 2 times x plus 3 over x times x minus 2 squared. Shh, guys. That does not make a hole because there's still a 2 in the bottom. So there's a vertical asymptote there, but not a hole. All right, but this was the question. So now what's left, there is a hole at 2.
Wait, that's the first out
From the bottom.
Oh, okay.
Yep. The bottom is what affects your vertical asymptote. So if you're getting rid of a vertical asymptote, it's not that wasn't part of my domain. It would still be undefined. So it changes from a vertical asymptote to a hole. All right, so now I would normally have, by roots, it's the same as zeros, it's the same as x-intercepts. Those are all the same thing. I would normally have one at 2 and I would have one at negative 3. But there's a point at positive 2, but it's a hole instead of a 0. So there's only one. It would be negative 3.
Isn't the multiplicity 2 the way?
No, because you lost it. You crossed it out.
Can you repeat that? But even if there's 2 of them, like.
There's not 2 left, though. There's only 1 left. This is what's left after we simplify it. So this is a vertical asymptote. This is a vertical asymptote. This is a 0. This has a point, but it's an open dot because it's a hole. So it does not count as a root. No, that was this example. I said that was hypothetical. That was if it was switched. The whole is from the denominator, not the numerator. So if you cancel out a factor in the denominator, that's when it's a whole, not the numerator. Correct, but there's still one left in the numerator, so there's still a point there, but it's a whole, so it's an open dot point. Yeah. Correct. Numerators get you zeros, roots, solutions, x-intercepts. All of those mean the same thing. Yeah. 16.
So it only has one state.
All right, 16. Well, she asked for 16. 16 says an angle theta is in standard position. It has a measure of 2 pi over 7. Which of the following is a coterminal? Remember, coterminal is add and subtract even multiples of pi. So if I take 2 pi over 7 and I add 2 pi, it'd be 14 pi over 7. I would have looked to see if that's an option, and it's not. 2 pi over 7 minus 14 pi over 7, negative 12 pi over 7. And that's the one that was there. 19. Oh, fun. All right, 19. Sign.
I tried to interpret this question in like 3 different ways. Me too.
Yeah, because you get the answer.
Okay, so first of all, you want them all to be the same trig function. Okay, I'm trying to think of what order I did it. I substituted first. So, these are all the same variable, right? I substituted a in. So I said a is 3x. So then I got sine of 2a, or sine squared a, minus cosine squared a, plus sine squared a equals 0. Then there's 2 sines, so 2 sine squared a minus cosine squared a equals 0.
Wait, but that, I don't think the last one is squared.
Oh, thank you. This guy? No, you're right. That's not squared. Okay, so don't combine them yet. So now you have both trig functions, sine and cosine. And when we solve equations, we only want one, right? So you have to think, how can I rewrite one in terms of the other? Can you rewrite a sine squared as something with cosine or cosine squared as something with sine? And the answer is yes, right? Because you can use your Pythagorean identities. But I wouldn't want to bring in, like, if you think about it, you've got a sine to the first. You can't get rid of that one, which means I'm going to get rid of the cosine by making the cosine squared 1 minus sine squared. So I get sine squared a minus, and they are both there being subtracted, so that the minus goes to both. So I put it in parentheses the first time, and then I would distribute. So it's sine squared a minus 1 plus sine squared a plus sine a equals 0. Now I can combine my like terms. 2 sine squared a plus sine a minus 1 equals 0. And that can be factored. So 2 sine and sine, positive 1, negative 1, and then split and solve. 2 sine a equals 1, sine a equals 1/2, sine a equals negative 1. But then a is not a, right? A is 3x. So this is your multiplying. So I'm going through this, and I'm not saying ignore this. I don't think it will be as complicated as this, but there are multiple skills within this that you are going to see. You do have to know how to factor. You do know how to replace your Pythagorean identities, and you do need to know how to deal with your multiple angles. So if you have something on your x, remember you find where this exists with the interval, and you adjust the interval. Now, if I looked at the answers, I would have seen the interval was there, so hopefully that reminds you I have to look at my interval. I can't just ignore it, okay? So sine is 1/2 where?
That's a really good question.
Pi over 6 plus 2n pi. Where else? Five pi over 6 plus 2n pi. Okay, no, then it's negative. Now it's negative. No, then it's negative. You need it to be positive. Where is sine negative 1? Oh, you just switched it. 3 pi over 2 plus 2n pi equals 3x. And then we got to divide by 3. So we multiply by a third, we multiply by a third, we multiply by a third. We change both the angle. So this becomes pi over 18 plus 2n pi over 3. And then 5 pi over 18 plus 2n pi over 3. And then multiplying by a third over there, pi over 2 plus 2n pi over 3. So as a whole, I think that's more difficult than you're going to see, but you are 100% see those things differently. Obviously, you're solving for trig functions. Obviously, you have to worry about your multiple angles and your intervals. You have to worry about your identities. And then, like, I just don't think a substitute and a substitute would need to happen. Like, you wouldn't have to do the A and then also do the multiple angles is what I would think. Yeah. Okay, 27 says the complex number 2 minus 2i is graphed in the complex plane. What's the corresponding trig form of the complex number? So we're going from complex and rectangular, we're the same process, to trig form. So if you're going complex or rectangular, which is your xy, to polar or trig form, those both mean the same thing, okay? So it is r cosine theta. In this case, you're in trig form, so it's plus I r sine theta. If it was polar form, it's just r cosine theta, comma, r sine theta. But basically, that process is the same thing. The only difference is if you're involving complex, you're going to have an I on the sine value because that's your B. So if it's 2, negative 2, because that's what it would be if it was 2 minus 2i, then the first thing you want to do is locate where it is. So 2, negative 2 means it's in the fourth quadrant, because there's going to be 2 right answers for tan negative 1. Then my r is the square root of x squared plus y squared. Square root of 4 plus 4, square root of 8, which is 2 root 2. If they were all the same r's, I wouldn't obviously even waste time doing that, but those are different. So that rules out C and D. Then I have to figure out which angle is it. Look at my choices. Like, already I said it's in the fourth quadrant. And 3 pi over 4 is in the second quadrant, and 7 pi over 4 is in the fourth quadrant.
How do you know it's fourth quadrant?
Because my coordinate point is 2, negative 2. So you go to the right, but you go down. So just that alone gives you B. But let's say that there were mixed angles in there. I want to do tan negative 1 of y over x. So I do tan negative 1 of negative 2 over 2, which is tan negative 1 of negative 1. And where on your unit circle is tangent negative 2, second quadrant, fourth quadrant at the over 4. We already know it's fourth quadrant, so we pick the over 4 in the fourth quadrant, which is 7 pi over 4.
Thank you.
You're welcome. Yeah.
Could we have just actually done
Huh?
swap cosine of 7 pi over 4?
Like worked backwards?
Yeah.
Sure. You could work backwards and see which one will give you the initial coordinate point. Sure. Yep.
Could you do some?
All right. 28. Back to rational functions again. You guys definitely need to focus on these. For the love of God. And I promise you it's on every single practice test multiple times. You're going to see it. Rational functions, wholes, vertical asymptotes, horizontal asymptotes. Like more than, I would say, 3 questions minimum out of your 28. All right, so it says, let A, B, C be real numbers. Which of the following is true about the graph of the rational function? Shh, guys. Shh. X plus B cancels out. What's left is X. And then X plus A squared. And then X plus C squared. Okay? So when you go through, shh. First of all, the fact that I crossed out this means there's a hole. That eliminates A. There's only one hole, so that eliminates D. Now I'm between B and C. Has 2 vertical asymptotes and 1 hole, 1 vertical asymptote and 1 hole. What's left in my denominator is only one term. It's squared, but there's only one term, which means there's only 1 vertical asymptote. It would be at whatever negative C is. So that's why it's C.
I have a question.
Yeah.
Does that like make a bounce or something, or is it just?
Not a vertical asymptote. That would be if it's in the top.
Oh.
Yeah.
So that's a vertical asymptote. Does it have an even multiplicity?
No.
It's just a vertical asymptote.
Yep. That's what he was just asking. It's not like a bounce is like the top. There's a bounce here, but it really doesn't matter. Yeah. It will change your sign so they both might go up or they both might go down instead of opposites. Yeah.
So if there's a hole, but like the multiplicity is still higher, it's not a zero.
If there's a hole but the multiplicity is higher in the bottom, then it's not a hole. Is that what you're saying? Or if
No, if the multiplicity is
higher in the top, then there's a hole. There's an open dot at the zero, but it's a hole.
so it's not a zero.
Correct. It eliminates it. It makes it undefined.